Okay, so we have this tricky question here under equations of linear motion. So it says a stone is projected vertically upwards with a velocity of 20 meters per second. 2 seconds later, a second stone is similarly projected with the same velocity. When the two stones meet, the second one is rising at 10 meters per second. Neglecting the air resistance, calculate the, Roman figure 1, length of time the second stone is in motion before they meet. Then 2, the velocity of the first stone when they meet. So the best way you can attack this question is to give a pictorial representation of the motion of the two stones. So this is the ground level and this is the initial velocity 20 meters per second of the stones. But now the first stone is already here and the second stone is here, and of course this is where they meet. And I'm doing it this way because it said when the two stones meet, the second one is rising at 10 meters per second. So this is when they meet. So if they meet here, this second stone is still rising at this particular velocity and the first stone is here. And of course, just by looking at this diagram, we can answer Roman figure 2 just by looking at this diagram, because we know that if you connect this first stone and the second stone with a straight line and the line is parallel to this to the earth or to the ground floor, we know that they are at that point in time they have the same speed. So the magnitude of the velocity will be the same. So this stone at this point in time will be moving at the rate of 10. We're moving downwards. Oh, like the arrow is supposed to go this way. We're moving downwards at the rate of 10 meters per second also. So supposed to be downwards. So going this way and coming down. The arrow here shows it's going up and the arrow this one shows it's coming down. So the first question says the length of time the second stone is in motion before they meet. Of course, this is where they meet. And now they're on the same level above the ground. And this stone is already moving at this particular velocity. And it was initially moving at 20 meters per second at the beginning of the journey. And it's now moving at 10 meters per second. Of course, the acceleration will be negative because it is now experiencing retardation. And it means that the velocity is reducing. The magnitude of the velocity is reducing as the stone is going up. It was 20, it reduced to 10. Then when it gets to the maximum height, the final velocity will now be 0. Then when it's coming down, the acceleration is positive because the speed, the magnitude of the velocity will be increasing as the stone is coming downwards. So let's get the time. To get the time it will take for the stone to get to 10 meters per second, that's what they want you to find. Length of time the second stone is in motion before they meet. So, and this is where they met. So since they met here, it's already moving at 10 meters per second when they meet. So we can use the equations of linear motion. We have V equals U plus GT. And we have, let me use something that will be tick. And we also have this equation 1. We have equation 2. H equals, I'm using H now because of we are dealing with height now. H equals UT plus half GT squared. Then the last one will be V squared equals U squared plus 2GH. This is equation 3. So let's get the time it will take for this stone to move from here to here when it now finally meets up with the first stone. So let's get our parameters first of all. We know that the initial velocity is 20 meters per second and the final one is 10. V is 10, final velocity is 10 meters per second, and our G will be a negative one since the object is going up and the speed is reducing. That's minus 10 meters per second squared, and our time is what we're looking for, so T and a question mark. So we have UVGT. So this is UVGT. So equation 1 will be our game changer. So writing out equation 1, we have V equals U plus GT. Then we have, what's our V? 10. We see 10 equals, what's our U? 20 plus our G minus 10 times T. So we have 10 equals 20 plus times minus minus 10 times T is 10T. Then collecting like terms, The plus 20 moves over to the left and becomes minus 20. So we have 10 minus 20 equals minus 10t. Then 10 minus 20 is minus 10. Minus 10 equals minus 10t. Then dividing both sides by minus 10. So dividing both sides by minus 10. So minus 10 cancels minus 10. Minus cancels minus 10 in 10 is 1. So we have t equals 1. T equals 1 second. So this is the solution to Roman figure 1. So this is Roman figure 1. It has been settled. So we now know the length of time the second stone is in motion before it meets up with the first one. So for question 2, or Roman figure 2, it said the velocity of the first stone when they meet. So how fast is this stone moving when they actually meet, or when it is actually like this? So we know it's 10 meters per second, and I've explained why at the beginning of the video. So, but we can give a calculation, give a proof that, okay, this is the calculation to show that this is 10 meters per second. The first stone is moving at 10 meters per second. We can get the height that the two stones will, their maximum height, because they're moving at the same speed, so they will reach the same maximum height. And this is our maximum height here. And you know that at maximum height, our v is 0. The final velocity will be 0 when going up. And when coming down, the initial will be 0 when coming down. So when going up, the at maximum height, the final will be 0. Then when coming down, the initial will now be 0. Don't forget that, very, very important. So let's get the maximum height, our h. So the h. So let's get the h. And the reason why I'm trying to get the maximum height, it will help us get the speed of the first stone. If you get the maximum height, then you can now get the height that this stone has covered at this point. And when you get the height it has covered from here to here, you can get the remaining height by removing this height from the overall height, and you get this height here. And once you get this height here, it means you have gotten the height that this one has moved from the top also. So once you get here, it means you have gotten the distance that this stone has covered, or yes, has covered while coming down. And once you get the distance that this first stone has covered while coming down, you can now get the velocity of the stone using your preferred equation here. So that's it. So once I get here, it means I've gotten here. Remember, they're on the same level. So if I get the distance here, I've gotten the one here. And when I get the distance here, it has solved my problem. My work will now be very easy. So let me get the overall distance. So h is question mark. Initial velocity is 20 meters per second. You know, that's it here. Then the final one will be 0 at maximum height. Don't forget. Then yes, our g will be minus 10, since we are looking at the object that is going up. Minus 10 meters per second squared. Then let's just see the equation that will help us out here. HUVG. HUVG. Yes, equation 3 will do the magic. So we now have v squared equals u squared plus 2gh. So we are looking for h. So our v is 0 squared equals our u is 20 squared plus 2 brackets, g is minus 10 times h. So we have 0 squared is still 0, 20 squared is 400, that's 20 times 20, plus times minus is minus, then 22 times 10 is 20, times h is 20h. Collecting like terms, this plus 400 moves over to the left and becomes minus 400. So minus 400 equals minus 20h will be left on the right hand side. Divide both sides by minus 20. So minus 20 cancels minus 20, minus cancels minus here, 0 cancels 0, 20 40 is 20, so 20 equals h, or we'll say h equals 20 meters. So that means our distance is actually, our maximum height is 20 meters. So if the whole height is 20 meters, 20 meters, so let us get the height that this first stone covers at this point in time, or has covered at this point in time. So the height of the first stone, let's get that one. So let's see the height of this. This is the second stone actually. The height of the second stone. This is the first stone. The height of the second stone. So we're going to say the height is question mark. The G is still minus 10 meters per second square since it's going up, and the time is 1 second. Remember, it's after 1 second, but we won't be needing, why not be needing that? It's 1 second here. We solved it. So 1 second. Then what else do we need? Yes, the initial velocity is 20 meters per second. The final is now 10 meters per second. So what do we need? We can exclude the time. We just have HGVU. HGVU. So this third one also works out. Will also work out for us. So we now have, using the third equation again, we'll have V squared equals U squared plus 2GH. So the final one is 10. So we're going to use 10 squared equals, the initial one is 20 squared plus 2 times minus 10 times the H we're looking for. So we have 100 equals 400 plus times minus 2 times 10, 20 times 8, 20H. Collecting like terms, we have 100 minus this 400 equals minus 20H. Then 100 minus 400 is minus 300 equals minus 20H. Dividing both sides by minus 20H. Minus 20, dividing both sides by minus 20 actually. Minus 20 cancels minus 20, minus cancels minus 0 cancels 0. 2 in 30 is 15. So 15 equals H. So the height. So from here to here is 15 meters. So that means from here to here is actually 5 meters. So if from here to here is 15 and everything should be 20, this is 5, and also this is 5 meters also. This is 5 meters. So we can now calculate the speed of the first stone, since we now know the distance it has covered while coming down. So for the first stone now, our H is 5 meters. The initial velocity while coming down, I told you, will be 0. Then the final is what we're looking for, question mark, and our G will still be plus 10 now, plus 10 meters per second square. So fixing those values into HUVG, this one is still going to work out HUVG. So we're still going to use V squared equals U squared plus 2GH. Fixing the values, you have the V squared equals, our U is 0 squared plus 2 times 10 times 5. So this 0 squared is nothing, it can go. So we end up having V squared equals to 2 times 10 times 5 is 100. Then, of course, the 2 leaves here and becomes 1 over 2 for 100 and becomes a power of 100. So now becomes 1 over 2 here for 100, and any number raised by 1 over 2 means you're finding the square root of the number following laws of indices. So V equals square root of 100. So the V equals 10 meters per second as we predicted at the beginning. So that's it, very simple.